Again, the area of the circumference of the circle is pi d. So the theorem of the pi, therefore pi, is equal to c divided by the diameter. Okay, so that's very easy. And same as with corollary, if c is the circumference of the circle, then with the diameter of the length, as I have told you, pi d or 2 pi r. Let's start example 1. Find the circumference of the indicated circles. So if the radius is given, you have to use the formula 2 pi r, right? So 2 pi. So we have, in terms of pi, 2 times 3 point, oh no, let's see, 2 pi. The radius is given, which is 4.5 centimeters. So therefore, the circumference is 9 pi. And on letter B, if the diameter is given, don't multiply it by 2. If the diameter is 50 centimeters, so C equals pi D. So pi times 50, which is equal to 50 pi. If you are asked to convert the pi into 3.14, and that's the time that you have to change the pi into 3.14 and multiply to 50 or on 9. Okay? So this is not new for you. And letter C, we have letter C. C is the, okay, since the letter is C, CW is actually the diameter. So we cannot use actually 35 and 12, but we can use the Pythagoras theorem. On letter C, we are going to have, since the diameter is CW, so that is the hypotenuse. So let us have that CW as the diameter is equal to the square root of the sum of 12 and 35. So 12 squared plus 35 squared, which is equal to 1,369, which is written on the book. And then the square root is 37. That is D, or the diameter. So now we can find the circumference. So circumference is equal to pi d. Since d is 37, so we have 37 pi. And that is in terms of centimeters. Okay? Now, what about letter D? Okay. Letter D, it's a circle circumscribed by a square. So let us see this, letter D. And then the side of the square is 15, right? It's not a square. All right. So this is 15 centimeters. And then there is a circle inside. So a circle inside. Let's try to use, if I can be able to use my intelligent pen. Oh, it's not fitted. I can use this to move. Oops. So let us make this smaller. Bigger. Okay. So let us assume that, wait, just wait. Okay, I'll make this this one a little bit. Yeah, okay. All right. So this is 15 centimeters. So it means that the diameter is also 15 centimeters, right? So we can get now what happened? The circumference of the circle. So C, so this is also the same with that, right? So that's the diameter. So C is equal to pi D. So 15 times pi. So 15 pi centimeters. Clear? This is a little bit easy. So let's go to number 2. The circumference of two concentric circles by 10 inches differ by 10 inches. Compute the width of the ring between the two circles. Okay. So again, the circumference of two concentric circles. So let us try to have two concentric circles. All right. So let us move this. Wait. But let us move it a little bit here. And my flow work is on wood. I can use it well. So let us try to have, these are concentric, means they have the same center, right? Oops. They have the same center. All right. Okay. The circumference of two concentric circles differ by 10 inches. Okay, compute the width of the ring between the two circles. So the width, we are looking for the width of this one, right? We're looking for the width. The width of the two. So let us see this. This is the width of the two circles. Let X with the width of the original ring. And R is the radius of the inner circle. So let us try to make R. This is R. This is the R. And that's the inner circle. And the width of the ring. And this is W, X. Okay. So then the radius of the outer circle is R plus X. Okay, so R plus X. That is the radius of, let us say, big circle. And then the smaller circle, the radius of the smaller circle is R. Okay. So now let's have the circumference of the outer circle. What is the formula for the circumference? Circumference is the radius times 2 pi, right? So let us try to get the circumference of this is the bigger one. So circumference is 2 pi r. And then the radius of this is r plus x. So let's change 2 pi and r plus x. That is for the bigger one. And then for the smaller one, circumference of the smaller one is 2 pi r because the radius is r only, right? So let us go back to the problem. The circumference of two concentric circles differ by 10 inches, right? So if you will subtract the two, the big minus the smaller circumference will be equal to 10 because their difference is 10. So what is the circumference of the bigger circle? So the circumference is 2 pi r, let us distribute, plus 2 pi x. Again, we multiply these to r and also x, minus to the circumference of 2 pi r is equal to 10. And then let's combine like terms now. We cancel these two. And then therefore we have 2 pi x is equal to 10. So divide by 2 pi, and then we will cancel out the 2 pi. So x, and then that is x is equal to 10 divided by 2 is 5 over pi. Question, compute the width of the ring between the two circles. So since the x is pi over 5, so we can say that we will divide x by 3.14. So that's approximately what? 5 divided by 3.14, which you will get 1.6 approximately. And that is in inches. So this is about 1.6 inches. Did you get it?
Yes, po, sir.
Okay. So let's go to the area of a circle theorem. Okay. Theorem 120. The area. So what's the area of a circle? It's pi r squared, right? Area of the circle is pi r squared. So find the area of the circle with the radius 24 centimeters and 70 centimeters. So that is very easy. So example 3, we just have to substitute the radius. The radius is 24, so just get the area. Area is equal to pi times 24 squared. So what is the value? So pi, so let's get the pi as 3.14 times 24 squared, which is about 576 pi, or of course it is centimeters squared because it is area, or approximately that is 1809.6 square centimeters. And that's on letter A. And on letter B, if the radius is 70, so area is equal to pi times 70 squared. Get it in the calculator. That is 4900. That's pi square centimeters, or approximately 4,900 times pi, which is approximately 15,393.8 square centimeters. In entrance examination, they do not ask for this, but they ask for in terms of pi, okay? So get used to that. Archimedes, in his measurement of a circle, states that the area of a circle is equal to right-angled triangle, in which one of the sides about the right angle is equal to the radius and the other circumference of the circle. Okay, letter B. Let us see shaded region. So most entrance exam, they apply the areas by this, okay? So let us see letter B. Find the area of the shaded. Okay. So you know that you need to get the area of, so area of the shaded. Area shaded is equal to area of the outer minus area of the inner. Right? So the outer is a circle and the inner is a square. So we just only get pi r squared minus s squared. The square has s squared. So therefore, we will be having pi r is 8 minus the side is, that is This one is the same with this. Let us see. If that is 8, so I will try to prove if that is also 16, okay? So 16, 16. Okay, so since this is 45 and 45, this is 8 squared of 2 and 8 squared of 2. So 8 squared of 2 squared. So that's 8 squared. Let us see if that's 8 squared of 2 plus 8 squared of 2 squared is equal to 16. So that would be, I know this should be 16. This is 16. Because the diagonal should be 8, right? So 8, 8. So that would be 16 squared of 2. 16 squared of 2, 16 squared of 2. And that is how many? So 2 times 16 times 2. 16 times 16 times 2, that's 512 plus 512 square root of the answer. So 32. The radius is 8, right? So, so just wait for the diameter. So 8 squared, what is the area? Give the area. Let us see, 64 pi, right? But the square has its diagonal. So if I will see this, given this one, so this is a right triangle, right? So if that is a right triangle, let us see. All right. So this is only 8. Wait. This is only 8 centimeters, right? This is also another 8 centimeters. So if this is the diagonal, then let us try to get the value first of the side. All right. So we will be using, the square has the same sides. So let us see to use the formula as x squared and x squared. So x squared plus x squared is equal to 16 squared. So that will be 2x squared is equal to 16 squared, which is 256. And then we will divide it by 2. So x squared is equal to 128. That is the side square root of 128, which is 8 square root of 2. So meaning that the side is 8 square root of 2. Or to apply, as I have told you, to apply the side of, remember this, the side of the square is, if this is x, okay, if this is x and x, the hypotenuse is x squared of 2, right? So therefore, if we have this x is equal to 8 squared of 2, that is the side, so we will have 8 squared of 2 squared, which is the same as 128, all right? So therefore, 64 pi minus 128 is how many? 64 pi minus 128 is how much? Around 73.1 square. That is the area of the shaded, this one. we will remove the area of the square to the area of the circle. That is the area of the shaded. 73.1. So maybe they rounded off here. So that is 64 pi. That's why it is around 72.96. Let us see to get, let's just try to get 64 times 3.14. So 64 times 3.14 is about 200.96. And then minus 128, which is about 72.96. Okay. 72.96. 72.96. Because I use here 64 shift pi minus 128. It's 73.1. Because if you are going to use the calculator, the pi key, you will get 73.1. But anyway, 72.96 is around 73 already. So no, no difference. Okay? Question. Question on this question. Question in example 3. You have question? So let's go to the theorem 1-1. Okay. The area of a sector theorem. So the area of the sector theorem is area of the sector is equal to area, the A is the measurement of the arc length. The area of the sector, which is arc measurement, is A to the product of the ratio of 360 pi r squared. The A is the angle, or let us try to say the theta, times pi r squared. Okay, so don't forget this. And then later we will get the length of the segment. Okay, so let's try example 4. Again, the area equals theta over 360 times pi r squared. So get the angle and the radius, okay? So example A is 30 degrees. So A, number 4A. So the angle given is 30 over 360 times pi r is 20 centimeters, then square it. So as simple as that. So that is divide by 3, that's 1 out of 12, right? Times pi times 400. So get this and you'll get the area. So 400 pi divided by 12, which is around 104.7. Area is 104.7 square centimeters. And then this is 30 degrees. So you are looking for this, all right? Shaded one. So letter B, you're looking for the shaded. So the area, the angle that we are going to use is not 30, but we have to subtract 360 minus 30. So that would be 330. So this full angle is 330 to get that area. So 330 over 360 times pi, and then the radius is 4 squared. So remove that, and that's 33 divided by 3, that's 11 over 12 times pi times 16. All right, so get this, 11 over 12 times pi times 16. So the answer is 46.1. So the area is 46.1 square centimeters. Is it? 330 over 360. That's 14. Yeah, because I covered it. All right, so let's change it to 14. That's why it's smaller. So let's change it to 14 squared, which is not actually 16. So this we change. So that's 14 squared. So 14 squared, which is actually 564.4. All right. 564. Use the pi button so that it's easier. 564.4. Okay. Question on this. Area of the sector, it's clear. No, so we have still 30 minutes probably. So look at this. A segment. A segment of a circle is a region formed by an arc and the chord having the same endpoints as the arc. To find the area of the segment, you subtract the area of the triangle to the area of the sector. So this is the segment. This part is the segment. Okay? That is the segment of the circle. So area of the sector minus area of the triangle, that is the segment. Let us try number 5A. What is the area of the triangle, by the way? Area is half of base and height. All right? So you subtract this area to the area of the sector. Find the area of the shaded segment in the given figure. Letter A. So area A, we have area of the segment is equal to the area of the sector, theta over 360, times pi r squared, right? Minus by, subtracted by the area of the triangle, which is half of base and height. So let us try to get the area. So what is the angle here? So it is understood that that's 90 degrees. So 90 over 360 times pi, and then the radius is 6. Minus half of the base of the triangle, it's a 90-degree angle. So this is also 6, right? So in order for you to get this, so I will separate that. I will get the base first of the triangle. So this is 90. So we use Pythagoras Theorem for 6, and this is 6. So in order for you to get the base, it would be 6 squared plus 6 squared, and then square root. So that is the base. Let us try, that's P. So square root of 6 squared plus 6 squared is equal to 6 square root of 2. So this is 6 square root of 2. That is the base of the triangle. But the problem is we don't have the height. But since, all right, so base is, okay, anyway, this is the right triangle, so we don't need to do that. But you will be using this sometimes. If it is not a right triangle, 6 by 6, sometimes you will be getting this height, okay? All right. So anyway, it is a right triangle. This is the base and this is the height. So we neglect that. So base is 6 and then the height is 6, okay? Since this is a right triangle. Later, we are going to get this height and then that is the base, all right? So the base is 6 and 6. So therefore, we will solve this. So 90 over 360, that's 1 over 4. So let's do it one by one. 90 divided by 360 times pi times 36, which is 9 pi. So let us do that later. And 6 times 6, so actually that is 3. 3 times 6 is 18. So 9 pi minus 18, which is you will get 10.7. So the area therefore is 10.3. square centimeters. All right. Again, this triangle is a right triangle, so it's easy for you to get the base and the height. But anyway, later we will be using this base and the height if these are not the same. All right. I mean, if this is not 90-degree angle. So let us do letter B. Letter B. So the angle is 120 degrees. So area of the segment is equal to 120 over 360 times pi. And then the radius is 4. Minus base, half of base and height. So the base of the triangle is given, which is 4 square root of 2. So we will change the base to 4 square root of 2. It's given actually. 4 square root of 2. Multiply by the height, which is 2. It's written here 2. So let us get first the area of the sector. So 120 over 360 times pi times 16. And that is 16 pi over 3 minus this is times 2, which is cancelled. So 4 square root of 2. So minus 4 square root of 2. So the answer is approximately 11.1 square centimeters. That is the area of the segment. Okay. Clear?
Sir, isn't the base 4 square root of 3 po?
What?
The base po, 4 square root of 3.
3, sorry. Yeah, that's 3. Let's change it. Not 2. I thought it's 3. So that is 3. Let's change to 3. So that's 3. So approximately how many? So let's change that. Wait again. That is 16 pi over 3 minus 4 square root of 3. Thank you. So that's 9.8. Around 9.8. All right. Clear? Do we have more? That's the application. Okay, so let's continue this on where on Thursday, and just try to compute first numbers 1 to 10. Okay, numbers 1 to 10 here for your assignment. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay? You are not applying the sector. That you have to do this first, 1 to 10, all right? Numbers 1 to 10, page 215. All right? Page 215, and that would be